This is the continuation of the previous talk related to the generalized cost estimation and optimization of commuter and regional aircraft. So, if you have not watched that particular lecture, I would recommend that you first go there, have a look at it, and then you will appreciate the context of why we are talking about a regional airport cost estimation model. Let us start with the basic overview of this model. This particular model is a part of an systems engineering approach to air transportation, in which we want to consider the system of air transportation consisting of the aircraft, airport and the passenger and passenger related issues. So, this particular model allows a direct coupling between the aircraft and the airport. Okay. Now, the aim of this model is to take advantage of the build, own, operate and the build, own, operate, transfer approach for new airport development, which is being followed all over the world, including in India. Earlier, airports were built and operated by government agencies. In India, for example, we had the National Airport Authority or the Airports Authority of India. They were operating the airport. They only were developing new airports. But now we see there is a lot of participation by the private sector in airport development, airport operation. Initially, we give the contract to these companies for operating existing airports, and then we can also transfer the rights of the airport to that agency, and subsequently you will find that they will enter this business and also develop new greenfield airports. The purpose of this approach is to ensure that we get optimum investment for best returns. Otherwise, it can be a very wasteful expenditure. When the government does something simply because it is forced to do, there could be situations where there is a lot of wasteful expenditure. Now, what is the purpose of this model? The purpose of this model is that assume that there is one existing established air transportation hub, say Mumbai or Delhi. Now, we want to start services at a new location which has a potential for air travel but does not have an airport. For example, Shirdi. Today Shirdi has an airport, okay, but there was a time when there was no airport in Shirdi. So, now assume that some agency wants to build an airport in Shirdi to cater for the likely demand for travel between Mumbai and Shirdi. Okay. So, now this airport at Shirdi, you have to first acquire the land, then you have to develop the land, build the infrastructure both at the air side and the land side. All that is going to cost money. So, who is going to pay the money and how do we recover the money? So, this model assumes that some agency, whether private or government, does not matter, wants to estimate how much money we are going to put to set up this airport and to operate this airport. And suppose that amount is X and the agency decides that we want to recover that amount X over say 20 years through every passenger who flies. So, then there will be some user development fee which will be charged. So, each passenger who operates from that airport and takes advantage of the facility or the infrastructure will have to pay that money, and over a time if that money is added, it will recover the cost of the airport for operating it for those many years and for also setting it. That is the kind of background behind this particular thing. So, we want to estimate the airport cost to meet a given demand for air travel and or cargo. To estimate the operating cost of the airport, we are going to look at the geometrical details and the frequency of operation of a given aircraft. Normally airports operate multiple type of aircraft, but in this case we are saying, oh, there is no market right now, we are just evolving, we are just developing the market. So initially we will operate only one airport, one aircraft type. So therefore, here is the aircraft, there is a geometry of the aircraft, weight of the aircraft, etc. All of these will affect the airport layout and therefore the sizing and therefore the costing. So what is the appropriate airport? What is the minimum required airport for this aircraft to operate at this frequency? That is what this model does. And it is limited to only twin turboprop, commuter and regional aircraft, because that is the main focus of this particular research, right? Now, this particular airport model has several sub-modules. The first sub-module is the airport configuration. So we decided that it will be a single runway layout and the orientation of that runway will be in the desired location. So here we assume that there are no constraints from the availability of the land, because this is a greenfield airport in an area where there is no air transportation. So it's likely, it's an assumption, it may not be true, that land will be available and you can build the runway in whatever direction you want based on the Windrose diagram, which we will also cover in this course. So there are no constraints from the terrain, etc. Then there is the airport layout sub-module. This carries out the geometric design of the airfield. So based on the regulations, runway width, taxiway width, runway taxiway distance, all these things will be taken care. So for ease in classification and to look at the development of the airport over time, because airports do not remain stagnant, they evolve with time. So therefore, we have gone for classifying the airport suitable for a regional or commuter aircraft into 3 levels, okay. And then we estimate the setting up cost and finally we also estimate the operating cost. So this is what this particular airport cost estimation module does. Now let us look at the airport layout module. So we know that the layout of the airport is carried out under some regulations and rules. If you follow the FAA, there is an approach category which is a function of the approach speed, and the airplane design group which is a function of the wingspan. If on the other hand we follow the ICAO rules, there is always a code number for every airport which is a function of the reference field length, and a code letter which is a function of the wingspan and wheel track. In my lecture on airport design, I have already covered these things in more detail. I am just repeating here for completeness. Then runway and taxiway and apron are 3 important items of the air side. Their number, their dimensions and inter separation, and also from the apron to the building or runway to the building, all that are specified by the rules. So these are the 3 levels as I mentioned. First is depending on the need, okay. How many taxiways and aprons have to be provided? If it is a very basic airport which has only one aircraft type coming only once a day, then why do we need more than one taxiway and more than one apron? Okay. Similarly, if the passenger terminal building is going to handle only 1 or 2 flights in a day with no conflict, then you can size it for the number of passengers and a few other people who will be operating it. Now, as per the regulations in force, there are certain minimum equipment which are required for safe operation of aircraft at an airport. So we looked at the rules at that time and we came up with the minimum aeronautical equipment fit. Now what is the basis of this classification? First important basis is how frequent are going to be the flights at this airport. Are we going to have a situation that there will be one aircraft already sitting and one more arriving? Then we require more taxiways and also a bigger terminal building, because it will be catering to both the passengers who are departing and arriving. Or are we looking at a situation that there is only one aircraft at a time and after a reasonable gap of a few hours another one comes. So the extent of flight operations is one parameter. Then to make it relevant to the Indian conditions, because this model was developed for a study for Indian air transportation system, we looked at the database of Indian regional airports. And here I would like to acknowledge the support given to me by officials from the Airport Authority of India, who made available to me the data regarding all the small airports at that time which were there. Mr. Bhatura of Airport Authority of India, I need to thank him for providing information to me about the Indian regional airports. Now, based on the study of this particular database of airports, I came to the conclusion that the minimum fit of equipment that at that time was required at an airport in India to operate was a non-directional beacon or NDB, and some control tower, need not be a very tall building, some control tower with at least one VHF radio to allow direct communication between the pilot and the radio. Notice I am not suggesting that you definitely need to have a physical human air traffic controller. The level 1 airport or the most basic airport in this particular study is a completely unmanned airport, right, from the point of view of the requirements for the air traffic. Just equipment and VHF radio which can be operated by the pilot remotely. That is the concept we have gone for. As the level increases, we also provide manpower at the control tower to take care of the operations. And also the payment of an airport could be a rigid payment or a flexible payment. Normally the rigid payments are used or required for very heavy and large size aircraft, but we are looking at regional and commuter aircraft, so we found out that we can manage with a simple flexible payment. So the basis is based on operational hours, climatic conditions and demand for travel. The minimum fit is an NDB with a control tower with one VHF radio and a flexible payment. And the features are that we calculate the number of aprons and taxiways, we size the terminal building and identify the cost and the need for the aeronautical equipment other than the minimum. Minimum is there, but when the level becomes larger, you need more equipment and more facilities. If you compare the three levels of airports in terms of investment needed, the nav aids provided, the kind of ATC service provided, operations and hours, the level 1 airport is requiring least or the low investment. It has a tower with one NDB and a transmitting VHF, not even receiving. The ATC service is very simple, it is only AIS, which could be given directly by a recording. Operations are going to be under VFR conditions and the hours will be as required. It could be 2 hours a day or 3 hours a day whenever the flights arrive. Level 2 airport will require medium investment. In this level 2, apart from the tower NDB and one transmitting VHF, we will put a VHF radio and also an aerodrome beacon. We will now provide tower control services. The operations are still under VFR, but it will be operating for about 8 hours a day. And for level 3 airport, which is the highest category for this model, you will need high investment, because now you are going to put runway lights and approach lights, because you are going to operate for 12 hours a day. So you may encounter conditions where runway lighting and approach lighting is needed. You will add an approach controller now. So now you will add another person in the control tower, and the operations can now be under VFR or IFR for about 12 hours a day. These are the three levels of the airport, and you can understand that the cost and the complexity will increase from level 1, 2 to 3 as we go. Here is the layout or a standard layout of this particular airport. Now all the items that you see in black color are required for level 1 airport, which means you require one runway, you require the runway safety zone, you require at least one taxiway, one apron, one terminal building, one car park, and in this study we are assuming that because we are locating this aerodrome in the middle of virtually nowhere in a new location, you cannot expect people to travel from the city. So we will have housing of staff and accommodation on board. NDB is compulsory for every airport, so it's a black item. Then you have these windrows, right, and you have this airport boundary, the dotted line. This is required. Now, and in the control tower, you have one radio, but in the black there is no human being. When you go to level 2, in level 2 you see the things in blue color. So now you expect maybe 2 taxiways and 2 aprons, because there could be 2 aircraft present at the airport at any given time. Now you require aerodrome beacon for more accurate air traffic management. You also now have one control tower personnel and one extra radio. And the terminal building is going to grow along the runway length in this direction. So will the car park and so will the housing be. Okay. And when you go to level 3 airport, it's everything in red color. So you have runway lighting. I have shown only on one side, because you might not need at both the sides. Depending on the wind directions which are prevailing, you may operating only from one side. But if there is a requirement, you have to put one more runway lighting on this side. Now you have runway edge lights also. You have a third apron and a third taxiway, and now you have 2 controllers and 2 radios, and the buildings grow as mentioned. So this is the generic airport layout for level 1, 2 and 3 together. Let's have a look at the runway geometry. Okay. We all know by now we have done a study of the design of the airport. We noticed that we need all these parameters, the pavement, shoulder, etc. So one can easily calculate these numbers. These are all based on the ICAO and FAA regulations. Okay. And then there are some guidelines given for the minimum distance between runway to taxiway, apron width, minimum distance between that and build. All these numbers are given as per the ICAO regulations. What is the distance? So from that we can get the area of the land which is required. So with that you can calculate the setting up cost, because now with the geometry is fixed, you can work out how much will be the area of the airport. Then we are going to construct the pavement. So we can find the thickness of the pavement based on the weight of the aircraft and the tire configuration. Then you can also construct the building on the land side, the passenger terminal building, nav equipment as I know, plus there are some fire and rescue services provided based on the ICAO category. Now in many cases these facilities are provided by the local state government to incentivize, but in this case we have assumed that you will need to set up or make arrangements for a appropriate fire and rescue category. Operating costs are to do with staffing, to do with consumables and to do with the maintenance of the airport over so many years. So let us compare 3 aircraft which will require 3 different levels of the airport. The most basic and the simplest aircraft is the Dornier 228-200 with 19 seats. Then you have Saab 340B with 36 seats, and you have the ATR 72-500 with about 66 seats approximately. One can reconfigure to incorporate more or less seats also. So we will look at these 3 aircraft. Okay. Now we assume that the Dornier 228 aircraft is going to manage with level 1 airport, because there are 19 passengers, there is only 1 flight per day. So the building can accommodate maybe 50 people max, including the staff, including people who are coming to receive them. 19 people will come, 19 people will go, and there are a few other people who are required. So the ICAO code number is 2 and letter is 3, and the aerodrome category for is 3, right. This is utilized for the sizing of the fire and rescue services. Now for this particular aircraft you require a runway of 800 meters, width will be 23 meters, width of the airport will be 446. So half a kilometer is the width and 1 kilometer is the length of the airport. So the area in acres and average thickness of the pavement for a flexible pavement you can calculate based on the standard procedures is about 19.5 centimeters. Going to the next level, Saab 340B with 35 seats. Now you require to double the passenger capacity in the terminal building, because now you are operating 2 flights a day. They could be at the same time depending on the demand. So the code number increases, the code letter remains same and category of the fire rescue also increases. Now runway length also increases, width also increases, because width is based on ICAO regulations, based on the aircraft parameters. You can manage with approximately same width, but now you have nearly 1.5 kilometer length because of the runway length itself being 1290 meters. So you require 187 acres of area, and the payment segment is also larger because of the heavier aircraft. Going to category 3 aerodrome for ATR 72 with 66 seats, you are now looking at 5 flights a day, and therefore you need much bigger terminal building. Now all 5 will not come at the same time, so you can manage with about 150 capacity. So the code letter, code number changes, aerodrome category changes, runway length increases but not much, and because of that the airport is still only about half a kilometer wide, slightly more, but the length is more than 1.5 kilometers. So you require about 252 acres of land, and the thickness of payment becomes larger. So because of this, you can look at, now this is the old data, but just to give you an idea, the cost of setting up the airport for Dornier 228 in 1996 was estimated to be about 513 lakh rupees, 5 crores and 13 lakh rupees, which became around 10 crores for 340B and 14 or 15 crores for ATR 72. The operating cost also will increase depending on the staffing, maintenance and the wages of the fire station, because the fire category also is increasing. So about 8 lakhs, 12 lakhs and 17 lakhs. Now these numbers may seem very small today, but remember the numbers that you are seeing was calculated in 1996. Okay, so here is the graph that shows the comparison between the 3 levels of airports. Look at on the y-axis we have the percentage of total cost. So we notice that land costs vary from 55 to 70% of the total cost. That is the most expensive item actually when you set up a new airport. Then you have a cost of runway construction. Then you have the terminal building cost, you have the fire station cost. Now here you are only seeing the percentage values. This is not the numerical value. So you might wonder why in level 1, level 2 airport we have 33% and level 3 we have only 22%. It is only the percentage, because you can notice that other cost terms are there. So apron cost, taxiway cost, equipment cost is a very small fraction of the land cost. Thank you for your attention.